Now that we have looked at adding, subtracting, multiplying, and dividing functions, we're going to look at a new concept called composition. The first thing is to know the notation. So the notation for composition looks something like this. It's kind of like an onion. I have an outside function and an inside function, and I could layer this as many times as I want. I can also write it with this open circle. So here's what that would look like. You would have the F and the G in parentheses together. But now instead of that open circle, which meant multiplication, you're going to have an open circle. So it kind of looks like fog. So it's an open circle there instead of multiplication. So the open circle means composition. I remember it because of the O there. What does this mean? If you think about the idea of a function as a machine. So say I have my machine, f of x, takes whatever I put in and double it, and g of x squares whatever I put into it. So if I look at what I've written here, f of g of x, what I'm saying is I'm going to start with my blue machine and plug something into it, and then I'm going to take out that answer and plug it into the red one. So I can put in whatever number I want to do to this. So if I want to find f of g of 3, I'm going to first plug in 3 to g of x. So I'm going to take 3 and square it, which gives me 9. And then I'm going to plug that 9 into f of x. So I'm going to double it. And I get different answers if I change the order. So that was finding f of g of 3. What if I want to find g of f of 3? That would mean I need to plug it into my 2x. I need to plug it into f of x first, and then take that answer and plug it into g of x. So I would say 2 times 3, that gives me 6. And now I'm going to use that input, 6, and square it, and I get 36. So that's just kind of a visual representation of what we're doing. We're taking one output and putting it in to another equation. The first thing I like to do in these problems is if it's written with that little open circle, I like to rewrite it in the other form. So here we have, let me color code all my stuff again. I have f of x, g of x, h of x. Well, let's do just h of x. We don't use j on this one. Okay. So if I want to do g of h of 2. So notice how I read that. G of h of 2. That's saying I'm going to do g is my outside and h is my inside. So the first thing I'm going to do is plug in 2 over here in h of x. So 2 times 2 is 4 minus 7 is negative 3. And now I'm going to do g of negative 3. I'm going to take what I just got out and plug it into g of x. So g of x is squaring something and adding 1. So I'm going to square negative 3, and that gives me positive 9 plus 1 is 10. The next one is already nice and written for me. So we're going to do h, which is my red function, of j of 5. So the first thing I need to do is plug in 5 over here to j. So square root of 5 minus 5. Well, 5 minus 5 is 0, and the square root of 0 is 0. So j of 5 is 0. And now I'm going to take that answer of 0 and plug it in to my other function, h. So 2 times, I just got 0 minus 7. 2 times 0 is 0, minus 7 is negative 7. Sometimes we see this weird thing right here where I'm plugging it into itself. I'm using the same function both times. All right, so I'm going to plug in 1 to g of x over here. So something squared plus 1, and the something I'm plugging in is 1. 1 squared is 1, plus 1 is 2. So I just said g of 1 is 2. So I'm replacing g of 1 with 2. And now I plug in 2 back into that same function. Squaring it plus 1. 2 squared is 4, plus 1 is 5.